And on 651, title it pi over 12 questions. And we're going to do a bunch of pi over 12 questions. As we introduced yesterday, this is one of the main reasons we learn the alpha plus beta formulas. So we're going to try to find the exact value of cos of pi over 12, or sine of 75 degrees. And in green here is the strategy that we're going to use the values that we know. We know our pi over 3, pi over 4, and pi over 6 families. The nice thing about the pi over 3, pi over 4, and pi over 6 families is you can make them have a denominator of 12, because pi over 3 is 4 pi over 12, and 3 pi over 12, and 2 pi over 12 for pi over 4 and pi over 6. And then you just try to add or subtract until you get the angle that you were trying to find. So for example, with A, cos pi over 12, well, cos of pi over 12 is the same as cos of 4 pi over 12 minus 3 pi over 12. So we got cos of pi over 12 is the same as 4 pi over 12 minus 3 pi over 12. And if I rewrite those, because 4 pi over 12 is just pi over 3, minus 3 pi over 12 is pi over 4. And those are both values on your pi plate. Some of you might have been able to see that it's not the only way that you could get pi over 12. Did anybody see that if you took 3 pi over 12 and subtracted 2 pi over 12, that would work as well? And if you did that, you would get exactly the same answer that we're going to get when we solve this. Now, the reason we do this is now we can think of this as alpha and this is beta. And we can go to our formula and say, well, my formula for cos alpha minus cos beta is cos alpha cos beta plus sine alpha sine beta. And now I can write this out. And now we know alpha. So when we know alpha, we plug in alpha, starting with cos alpha cos beta plus sine alpha sine beta. And each of these values is on your pi plate. You know what cos of pi over 3 is? It's 1/2. You know cos of pi over 4 is root 2 over 2. You know that sine of pi over 3 is root 3 over 2, and sine of pi over 4 is root 2 over 2. When we multiply these out, we've already got a common denominator of 4. 1 times root 2 would be root 2. Root 3 times root 2 would be root 6. You can't add root 2 and root 6 together, so we're done. We've written as a single fraction. And now we've found the exact value of cos of pi over 12. You can do the same thing in degrees. Now, thinking about your pi plate in degrees, can you think of 2 ways that you can get, or can you think of a way that you could get 75 degrees? 45 plus 30, okay? So the first step we do is we rewrite it, 45 degrees plus 30 degrees. Working from that, this is my alpha, this is my beta. Sine alpha plus beta formula says sine alpha cos beta plus cos alpha sine beta. You forget the degree sign once, then you're talking radians, and then your question is no longer accurate. So there's, on the exam, they would take off a half a mark deduction if you forget your degree sign once. Now each of these are on our pie plate. Root 2 over 2, root 3 over 2, root 2 over 2, and 1 over 2. Again, we're going to have a common denominator of 4. It's going to be root 6 plus root 2. Exactly the same answer as before. 75 degrees, by the way, is the same as, in radians, 5 pi over 12. So we're really finding out about all of the pi over 12 families. I can tell you right now that no matter which pi over 12 family you do, if you do sine or cos, you will always get a root 6, always a root 2, and always over 4. What changes is sometimes the root 6 is negative and sometimes it's positive. Sometimes the root 2 is negative and sometimes it's positive. But as far as recognition goes, if you get a root 6 or root 2 over 4 for sine or cos of a pi over 12, you most likely have the right answer. For tan has lots of root 3's in it. What's that? You could now add these to your pie plate. Now we're going to do one that isn't an easy pi over 12 one. Okay? 17 pi over 12. I'll show you. If you're wondering about spacing for your, there's a little part D to it, which won't take very much. Okay? Yes? No, that's a good question. Okay? I'm going to just go to that question on a different screen, and then I'll go back. His question was, if I have cos of pi over 3 plus cos of pi over 4, can I distribute and say, is this true, cos of pi over 3 plus cos of pi over 4? The answer is no. Cos is a function, it's not a number. So as a function, we're allowed to distribute, like if there's a number out in front like a 2, or if it was cos of pi, that would be a number, because that's equal to -1, then you could distribute it. But when it's just a function, the only thing you're allowed to use are your identities and your formulas. So the only thing that cos of pi over 3 plus pi over 4 would equal would be cos cos minus sine sine. But it's very tempting to do this, okay? But it isn't true. Just like if I had something like this, right? Are you allowed to just cancel out the ends? No. Even though it works, okay. All right, we're going to go back. So now we have 17 pi over 12. The key thing to figuring these out is if you look at the families that you know, pi over 6, pi over 3, pi over 4, when you make them over 12, which we had written down earlier, 2 of them I'll go back up here just for a second. Pi over 3 and pi over 6, when they're over 12, are both even numbers. Only pi over 4, when you make it over 12, makes an odd number. And every pi over 12 family that we're going to try and solve will always have an odd number on top. Otherwise, you could reduce it to a pi over 6 family. The only way that you're going to get an odd number when you're adding two things together is if one of those is an odd number. So you always have to have pi over 4 in every single pi over 12 question. There will always be a pi over 4 family. And you can choose any pi over 4 family you want, and it will always work. So for cos of 17 pi over 12, randomly pick, if you want, one of those pi over 4 families. They will all work. Which one do you want to pick? 7 pi over 4. So 7 pi over 4 is 21 pi over 12. Now, in order to make it equal to 17 pi over 12, what would we have to do? We'd have to subtract, right? How much would we have to subtract? 4. And then, because we chose 21 pi over 12, which happens to be 7 pi over 4, when we reduce 4 pi over 12, we realize, oh, it is another family member. And it will always work to be another family member if you start with your pi over 4 family. If you start with pi over 3 or pi over 6, you might get something that doesn't work. So now this is my alpha and this is my beta. And I'll get cos 7 pi over 4 cos pi over 3 plus sine 7 pi over 4 sine pi over 3 using my formula. What is cos of 7 pi over 4? Pi over 4 family, root 2 over 2, positive or negative? What quadrant is 7 pi over 4 in? Quadrant 4, so it's going to be positive. Cos of pi over 3, 1/2. It's quadrant 1. It's going to be positive. Sine of 7 pi over 4, root 2 over 2. Quadrant 4, though, for sine is negative. And sine of pi over 3, root 3 over 2. So we're going to get, again, common denominator 4, root 2 minus root 6 this time. Now, typical of the last couple of exams, sometimes they'll ask cos of 17 pi over 12 as a part A, and then as a part B to this question, they'll ask secant of 17 pi over 12. And if they ask secant of 17 pi over 12, well, we just take the answer that we found in A and do the reciprocal. About 4 or 5 years ago, this was the entire question, but they found too many people got stuck, didn't know where to start. But if you did get secant of 17 pi over 12, solve cos of 17 pi over 12 first, just like we did, and then whatever answer you get, flip it at the end. But sometimes this will show up as a part B. Part A you do, they're sort of leading you to the right answer. And the nice thing about this is even if you don't know, I shouldn't tell you this, but if you don't know how to solve part A and you get some sort of fraction, whatever fraction you get, if you show that you know for secant that you have to flip it, you get full marks even if the answer is wrong. So show that, because this is really just asking, do you know that secant is the flip of cosine? So whatever answer you got in A, as long as you flip it in part B, you'll get a follow-through error mark. and because you know the concept that they're looking for. Oh, and I got